My name is Shubhodisha. Welcome to our YouTube channel Helm of Science. Today is the last part of the nomenclature of nomenclature of alkane. Today I will discuss the cyclic part, the cycloalkane. So today I will be discuss the nomenclature of cycloalkane. Now what is cycloalkanes? Suppose before starting nomenclature I will show you one example. Suppose what is the name of this compound? It is normal propane. Okay, this is normal propane. But if I write the structure like this one, I draw the structure like this one. Okay, fine. I just tilt the two CC bond at the end. Okay. Now I am removing hydrogen from each carbon present at the end. Okay. Fine. I remove the each hydrogen from the carbon which is present in the end or terminal position. Okay, fine. So now the valency of this carbon and this carbon is 1, 2, 3, 1, 2, 3. So one more single bond is needed to complete their valency. Okay. In this case, now this carbon and this carbon will form a bond. Okay. This is actually cyclic structure of any aliphatic compounds arise. Now the next question is, this is not stable. This is not stable. So why? What is the necessity to form a cyclic compound using same number of carbon? What is the necessity? And you also see this propane is freely rotate. This propane is free. This is very much stable. But in this case, there is a very much strain. That is a 3-member. If you take the two CH3 at the end and tilt and make a bond between them, then it feels a strain. That's correct. This feels a strain. So my question is, why, if it feels strain, why a cyclic compound will form? Why cyclic compound is formed? This is stable. What is the necessity to form the cyclic part, cyclic structure? Think twice. Pause the video. Think twice. Then I will give the answer. You know the answer. In first class, I have discussed each topic very carefully, each fundamental topic very carefully. That fundamental topic takes a great role to explain why cyclic compound will form. Okay? Now I am giving the answer very carefully. In this case, if I suppose here this is CH, fine. I can open up this CH3. I am opening up this CH3. Fine. If I opening up this CH3, what happens? What is the bond? CH bond. Okay. CH bond. Okay. CH bond. Now here also a CH bond. But when I removing one hydrogen from each carbon at the present at the end, we get a CC single bond. Now think, which bond is stable, CH or CC? Now think, which bond is stable, CH or CC? We know the catenation power of carbon, that carbon have the property of self-linking. That is nothing but our catenation property. That is why, that is the fundamental of organic compound. That is why organic compound is so much famous. That organic compound is so much researchable. That carbon, single bond, double bond, triple bond, this catenation power takes place. That is why, in spite of having the strain of this molecule, C single bond, C will form. That is the reason of formation of cyclopropane. That is not present in our syllabus, but IUPAC nomenclature. But you have to take the feel. Why is the necessity of formation of cyclic compound? It is stable. What is the reason to take so much strain? This is a 60 very much strain. The angle is 60 degree, very much strain. There is no strain. And angle strain is taking place a very important role. In spite of the strain, why the cyclic compound is formed? The reason is C single bond. The catenation power of carbon will produce the formation, will force to formation the cyclic compound. Okay. Now this is a basic idea of why the cyclic compound will form. That is not in our syllabus. Now I will discuss one by one the nomenclature of cycloalkanes. Now, what have I taught you about the structure of any IUPAC nomenclature? That is prefix, secondary, plus prefix, primary, plus word root, plus suffix, primary, and last one is suffix, secondary. Secondary. Okay, fine. Now, what are the prefix secondary? That is our substituent, halides. Okay, fine. Okay. Word root means mid, in, group. That means the number of carbon present in the main chain or long chain. What is suffix primary? That is alkane, alkene, and alkyne. We are discussing about only alkane, and what is suffix secondary is a functional. Okay. So in the cycloalkanes, today I am not discussing the suffix secondary part, that is functional group. We will explain further the suffix secondary part. We just discuss today the alkane part and cyclic part. Now, what was the prefix primary? I have written that prefix primary is nothing but some special structure, that is cyclo, bicyclo, spiro, etc. Okay, fine. That are the prefix primary. Done. This is the prefix primary. So today this cyclo part will be takes place a major role. Now, suppose this is our structure CH2, CH2, CH2. I am using the bond line notation. Fine, I am using the bond line notation. Now, what is the name? You all know the name is cyclopropane. It is very easy. But how the cyclopropane? Sorry for the inconvenience because my electric supply was gone. So now I am starting again. How the cycloalkane name is come. What is the prefix secondary in this compound? There is no prefix secondary because there is no any substituent group as well as there is no any halide. Now in this case, now there is first time there is a prefix primary is present. So what is the prefix primary? That is cyclic compound. This is our prefix primary. So prefix primary is cyclo. Okay. Word root 1, 2, 3 carbon. That means prop. This is alkanes. That is suffix primary. That is cyclopropane. That is how the cyclopropane name is coming. Fine. Now I am giving you. Now I am rubbing in all the things. You have idea that cyclo is the prefix secondary. After the prefix secondary, that is substituent. Prefix primary will take place the important role in IUPAC. Then word root. Then suffix primary, and only alkane N is included because today I am not discussing in, I and functional group. Okay, fine. Next, now I am going to the examples. First, starting with a simple example. Okay, fine. This is cyclopropane, and I am giving you this. What is the name of this nomenclature of this compound? First numbering 1, 2, 3. Okay. First prefix secondary 1 methyl, then prefix primary cyclo, then word root pro, and then suffix primary, that is pro n. Fine. Now I am running it. Now going to the next example. Suppose if I am giving you this one, this one. So what is the nomenclature? Are you basic? Look, methyl 1 methyl. Okay. Then how many carbon is present? 2, 3, 4, 5, 6. Then cyclo, how many? 6 carbon. X alkane hexane. Okay. And what is the name? 1, 2, 3, 4, 5. 1 methyl cyclo pentane. That are the very simple one. Now I am going to little more tricky. Fine. Suppose if I write it, first write this one. Okay. Now pause the video and try to solve this one. Okay. Now I am starting. Listen very carefully. There is two possible ways of the IUPAC nomenclature of this compound. What are the ways? Suppose here the substitute, that means prefix secondary may be this one, and prefix secondary may be this one. Okay, if this is our prefix secondary, that means substituent, then what is the IUPAC nomenclature? This one. One, 2, 3, 4, alkyl, propyl, 5, cyclo, 1, 2, 3, 4, butane. That is one case. And if I take this part, if I take this part as a substituent, then what happens? 1 cyclo, except butane. I use butane, that is because it is a substituent. Cyclobutane, 1, 2, 3, propane. Now the question is, which one is correct? Which one is correct? Both are possible. Both can be, maybe this can be maybe substituent, and this also may be substituent. Now what is the correct answer? Now when the word root is that which have the word root have reference of word root have maximum number of carbon. Now by word root have maximum number of carbon or any functional group or alkene or alkyne. So we have to select the word root which have a functional group, double band and triple bond. Fine. Now here the maximum number of carbon present in this cyclic part, not in this part. So our preferential nomenclature is 1 propyl cyclobutane. That is correct, not that. Okay, fine. I am going to the next example. That is another note and another rule. Okay, it is another rule. I am going to this problem. Now, suppose this is cyclopropane. Fine. Here the substituent is 3 carbon. So in this case, how do you select this one is substituent or this one is substituent? Here another note, write a note. If the number of carbon is same, if number of carbon is same, okay, then ring is more preferred than chain. Okay, so in this case, this is chain and this is substituent. So name is 1, 2, 3, 1 propyl cyclopropane. Got it? There is 2 rules. One is if the number of carbon is same, then ring is more preferential than chain. And another is the system having number of carbon, more number of carbon, functional group, and the alkene or alkyne, that is our expected working. Right? Now there is all rules. Now I am going to the example by example. Now I am doing first one. Okay. Right? So this is our complex substituent, and the name of the complex substituent is 1, 2. So 1 methyl, just a minute. That substituent is 1 methyl. Fine. This is the name of the substituent. So what is our IUPAC nomenclature? 1 dash 1, 2, 3, 1 methyl, ethyl, bracket close, cyclopropane. Fine. 1, that is 1 methyl ether, then it is our cyclopropane, and this group is attached with carbon 1. That is why 1 methyl ether, ethyl cyclopropane. It is very easy. Now the next problem. Now this is our next problem. Okay. Now what happens? Listen very carefully. If I starting the number, this is a simple substituent. There is no complex substituent, so there is no necessity of doing the nomenclature of complex substituent. Okay. Now, if I giving number 1, here is 1 and 2 and 3. So what happened? The what is the sum rule? Look at sum rule. 1 plus 2 plus 2, that is 5. And if I start give the numbering from here, so what happened? 1, 2, 3. That means 1 plus 1 and 2, that is 4. So we have to select the lowest logarithm rule, that is 4. So numbering is okay. Correct number is 1, 2 and 3, not previous one. Okay. Now what is the name of the nomenclature? Alphabetically, ethyl comes first. So 2 ethyl hyphen 1 comma 1 dimethyl cyclopropane. Fine. 2 dash ethyl 1 comma 1 dimethyl cyclopropane. That is also easy. Now pause the video and try to doing this one. Okay, pause the video. Be honest. Any of them you can solve in your own way. That is the that gives you very much confidence. Okay, so try to pause the video and try to do it yourself. So now I am free. Okay, so this is a complex substituent because it has a branch. Fine. So what is the name of this complex substituents? 1, 2, 3, 4. 2 methyl Okay, 2 methyl 1 2 3 4 butyl, that is the name of our complex substituent. So what is that? Now I am going to the direct total IUPAC nomenclature, that is associated with carbon number 1 dash in bracket 2 methyl butyl. Okay, then 1 2 3 4 5 6 cyclohexane. Okay, that is our nomenclature. Very simple. Just do the main part is doing the nomenclature of our complex substituent. Okay, fine. Now next one. This is very interesting. This is going to be very interesting. Now this one. Do it. Pause the video and try to do this one. Okay, then I will solve it. Now I am doing this. First select which one is word root. First select which one is word root and which one is substituent. There is 4 carbon present in this is cyclobutane or cyclic 4-member cyclic compound, that is 4-member cyclic compound having one CH3 substituent, and in this one 1 2 3 4 5 and 6. So in this case which one has the highest number of carbon? The adiabatic chain has highest number of carbon. Okay, fine. Open chain has highest number of carbon, more number of carbon. So this is our word root. This is our word root. This is our word root. So I have to now do the substituent part. What is the name of the substituent? 1 2 3 4 1 methyl cyclobutyl. That is our substituent part, and this is associated carbon number 1. So 1 dash 1 methyl cyclobutyl 1 2 3 4 5 6 carbon, that means hexane. Okay, that is our predicted IUPAC nomenclature. First select the word root and substituent. Here the number of carbon is 6 in the open chain, that is why this is our word root, that is why it comes hexane, and in this case one methyl present in the cyclobutyl group. So 1 methyl cyclobutyl 1, so 1 dash 1 methyl cyclobutyl hexane. This is our nomenclature. Okay, and now I am rubbing it. Now do this next one. It is very simple. Last one is very easy. Do this one. Look, starting from anywhere 1 2 3 4 5 6 or 1 2 3 4 5 6, because we have to select the carbon which having the lowest carbon having the substituent. So 3 ethyl dash 1 methyl according to the alphabet cyclohexane. That is very easy. This is very easy one. Okay, this is our first 5 problem. I will solve 2 or 3 problem, and my alkane nomenclature of alkane will finish. Okay. Now, the first problem is very interesting. Very. This is our first problem. Okay. Here, open chain have 1, 2, 3, 4 and 5 carbon. Okay. Now, in position 1 and 5, 2 cyclohexane 6-member ring is present. 6-member saturated ring is present. Fine. So, in this case, the ring have 6 carbon. That is fine, and the open chain have 4, 5 carbon. But here, the presence of 2 ring explain or reveals that in this case this 2 cyclo or 6-member cyclic compound is as present as a substituent. It present as a substituent. Okay. So now what happened? nomenclature 1 and 5. Sorry, 1, 5 dash di cyclohexyl 1, 2, 3, 4, 5 carbon, that is pentane. Understand? This is a very interesting problem. The substituent part having more number of carbon because of presence of 2 cyclohexyl group present. That is why it act as a our substituent, not word root, and word root is pentane. Fine. Now I am doing it. Next one. Very quick, very quick. So starting the number maybe 1, 2, 3, 4. So lowest sum rule 1, 2, 3. Locate sum rule is 3, 2. Sorry. 1, 2 and 4. 4 to the 6 and 7. But if I starting 1, 2, 3, 4. Okay, so 1, 3, 4. That is 8. So that is not correct. That is not correct. So first one is correct. 1, 2, 3, 4. Now 4 chloroalphabetically dash 2 ethyl dash 1 methyl cyclohexane is our expected IUPAC nomenclature. So fine. So now last problem of this class. Try it once yourself, then I will help you. Wait one. So this is our last problem. So in this case there is 2 cyclic group is present, that is this one and this one, but this cyclic group have higher number of carbon atom, so this act as a word root, and this one is act as a substituent. So name of the substituent is 1. Now very carefully, this is a CH2 part, that is methyl part. 1 methyl cyclopropyl, that is the name of our complex substituent. 1 methyl cyclopropyl, and now total nomenclature is 1 right bracket methyl cyclopropyl cyclohexane. Okay, fine. So this is our IUPAC nomenclature. 1 methyl cyclohexane, then 1 dash methyl cyclopropyl cyclohexane. So enough for today. So nomenclature of alkane is complete from my side. If you have any problem, ask me in the comment section, then I will solve a doubt clearing class for the cyclohexane. Next day I will go to the IUPAC nomenclature of alkene, and I am trying to do the alkene alkyne part is combined. This is because alkane part is very large, and if you learn alkane, then alkane and alkyne is not very easy, because in this nomenclature of alkane, we have learned complex substituent, we have learned the cyclic compounds. So on that part there is no so much trouble. That is more maximum 2 or 3 class I will take in for the our alkane and alkyne. Fine. So keep practicing, try to learn everything what have I taught in this 3 class. I am coming to the next video.